All right, how's everybody doing? I'm talking a little calmly right now because this is a super important video. It's one of those ones that it's going to be longer. Not going to lie, it's not going to be the fastest one, but it's a really important one. It's over solving quadratics. It's really an Algebra 1 topic, maybe even a math 8th grade topic, but I'm just going to tell you that some kids struggle so much in upper level math, pre-calc, calculus even, because they don't know how to do a basic quadratic solving. So please make sure you understand all the little teeny tiny details of this video. Even if you think you're great at solving quadratics, watch it, because there's a lot of little tiny details that could make these problems pretty difficult if you don't follow along. All right, so first off, what is a quadratic equation? All right, it's an equation where the largest power on the variable is 2. So we have the basic form, the standard form of a quadratic is ax squared plus bx plus c equals 0. I want to note a couple things. If you're going to solve a quadratic, you need it to equal 0. Doesn't mean there has to be a 0 there to start. You can have the c, the bx on the other side. Heck, you could have the ax squared on the other side. Or you could have a whole bunch of different things that got to combine together. But at the end of the day, if you're going to start solving a quadratic, you need to get a 0 on one of the sides. And you know what? It doesn't matter if it's on the left-hand or right-hand side, because you can just move it around to whatever way you want. But you got to make sure you do that, okay? Note that the a, the b, and the c are all terms, okay? Note that the terms don't all have to be on one side. It's like I already said that, right? This is just standard form of a quadratic, but if you're going to solve it, get them on one side. Also note that the a, the b, and the c are numbers, right? They could be fractions, they could be decimals, they could be whole numbers, whatever. But you gotta have an a. You can have a 0x, you could have a 0 in place of c. But you gotta have an a, because if you have a 0 for a, well then your x squared term is wiped out, and then you're no longer quadratic, you're now linear. So you gotta have an a value, whether it be 1, 2, 3, 4, negative 16, who cares, but you gotta have an a value. All right, now an equation, when we solve a quadratic, we're looking for an answer. And I'm going to tell you right now that every quadratic either has one answer, two solutions, or no solutions, okay? Now, weirdly enough, when we're working with quadratics, we call solutions a couple different things. We call them solutions, answers. We also call them zeros. A lot of times we say, oh, what are the zeros? That's just a fancy way of talking about the solutions. And some other really people, advanced people, not advanced, I don't know, mathematical people might call them roots. So what are the roots? Those are the answers, the solutions. Again, there's going to be 1, 2, or none. Okay? Now, sometimes answers could be rational, meaning that they could be turned into a fraction, like 3/4, 5/3, 2/5, even 1. Technically, 1 is a rational number because it can be made into a fraction, 1 over 1, 3 over 3. Even 17 can be turned into a fraction. So, whole numbers are also rational. But the answers to a quadratic sometimes be irrational. I mean, they involve a non-reducible square root, like the square root of 2, the square root of 5, the square root of 3, what have you. We'll talk about that. But that actually brings up a pretty important about giving solutions, giving your zeros, giving your roots, giving your answers. I like exact answers, okay? Exact answers are nice answers. I don't necessarily like approximate, right? So if it's rational and the answer is 2, that's an exact answer. Even if it's a fraction, 3/4, that's an exact answer. And listen, I don't mind decimals if they are terminating. So 0.75, for example, is a terminating decimal. That's a great answer. I love it. Another rational answer is 1/3. I love 1/3, but don't put 0.3. That's not 1/3. That's 3/10. Don't put 0.33. That's 33/100. That's not 1/3. So if the answer is 1/3, the only exact answer I'd accept is 1/3. If it's a terminating decimal, 3/4 or 0.75, either one is good. But any of these things, bad. All right, now, another thing you got to be careful is if those irrational solutions. So for example, the solutions to a quadratic could be 2 plus or minus the square root of 5, which means 2 plus the square root of 5 or 2 minus the square root of 5. Now, because the square root of 5 is a non-perfect square root, these are irrational, right? Anytime you involve a non-perfect square root in a number, it's going to be irrational. These are the answers I want, guys. You could go to your calculator, you could type in 2 plus radical 5, and you could get some decimal, right? I'm going to do it right now. I know you can't see me doing it, but I'm doing it, trust me. 2 plus the square root of 5 is 4.236067977, bunch of more numbers, right? That's approximate. Don't say, oh, well, the answer is 4.24 or 4.236. I don't want that answer because that's an approximation from a repeating, or not even necessarily repeating, a never-ending decimal. Remember, irrational numbers have decimals that just keep going and going and going. So I don't want those answers on a formal test or quiz or homework. I want the exact answer, 2 plus the square root of 5, 2 minus the square root of 5, what have you, okay? Now, the other thing I want you to be aware of is how do you list solutions? Like if there's only one answer, x equals 5, that's great. X equals -2, that's awesome. But if there's more answers, how do you type that in or how do you give that? I mean, you could write x equals 5 or x equals -7 maybe. That's fine. But a lot of times we just use brackets. Like we'll say, okay, the two answers are, in a bracket, 5, -7. And I know my brackets look just like giant squiggles. But again, you guys know what a bracket is. They're on your keyboard, right? They're right next to the O and the P. Right next to the P is where the brackets start. So again, that's how I want you to give answers. Well, that's an option, right? You could do this. You could write x equals 5 or x equals -7. I will tell you, though, in a lot of math programs that are web-based or computer-based programs, they're going to want you to give your answers in these brackets, 5, -7. Or again, check this one out, 2 plus radical 5, 2 minus radical 5. There's my two answers, exact answers. All right, so now I hope you guys understand when I say I want an exact answer, what I mean by that, and how I want you to list solutions. All right, now let's talk about solving quadratics. There's essentially 5 ways to solve a quadratic. I'll list them right now. Factoring and using what we call the zero product property. If you are really good at factoring, oh my gosh, that is one of the best ways to ever solve them. It's so easy to do. But let me warn you guys this. I don't do the easiest of factoring problems in this class. A lot of the problems I use in this class, they are factorable, but be careful. They might be factoring ones that you're going to have to think a little bit, okay? So just watch out for that. I don't give the easy ones. This is honors pre-calculus. All right, you could also use something called the square root principle. Now, that is best used when the bx is in the middle there is gone. There is no bx. But it could also be used even if there is a bx there, and that is the completing the square. The completing the square method, which a lot of kids hate, I'm going to try to convince you otherwise of that, but the completing the square method is just a way to go back and use the square root principle, but you got to complete the square first. We'll talk about that when we get to it. Number 4 is the quadratic formula. The one reason why I love the quadratic formula is it always works. Always. Like always as in always. It will always get you the right answer. Doesn't matter. So if you're like, oh man, I just want to get the right answer, then just listen, always use the quadratic formula and you'll never go wrong, okay? It's that easy. It might take you a while, but listen, it's going to get you the right answer. All right, and the 5th way is to look at the graph. Let me just talk about that real quick. We're not really going to do a ton of examples with that right now because I want this to be more algebra-based. But remember, when we're talking about a graph, if you graph a quadratic equation, remember, it's got to equal 0 first. It's got to equal 0. When you type that side that's non-zero into the calculator, maybe it's 2x squared minus 7x plus 5, whatever, just kind of made that up. When you type that into the calculator, you're going to get a parabola. And parabolas can look like this. And you will literally see the two solutions right there. Now, this is actually where they get the name zeros. They are called zeros. Solutions are called zeros because they are the two places where the graph equals 0. Now, remember, you might only have one solution, and that is where we just nick the x-axis, and there's only one solution. Or remember, you might have no solutions. Maybe you have an upside-down parabola like this that never, ever, ever crosses the x-axis, hence there's no solutions. So, you know, another way to always check your work, right, is pull out your calculator, go to Desmos.com, type in the equation, and look at the graph. Where it crosses the x-axis, whether it happens 2 times, 1 time, or no times, those are your solutions. So that's another really, really easy option. And I actually recommend you doing that to check your work all the time. All right, so let's talk about the different techniques here. Let's run through them as fast as we can. But again, this is not going to be a short video, so please pay attention. All right. Factoring and using the zero product property. Now let's talk about what the zero product property is. The zero product property says if A times B, a number times another number, equals 0, then either A equals 0 or B equals 0. Because if A and B are both non-zero numbers, when you multiply them, you're going to get a non-zero number. So if A times B equals 0, then one of them absolutely, positively must equal 0. So when we factor a quadratic, what we're doing is we're factoring it into two linear factors. And one of those two factors must be 0, right? So when we factor, there's a couple things we got to be aware of. First, you got to have a 0. Don't ever factor, and I mean don't ever factor unless you have a 0 on one of the sides. And if the 0 is on the left-hand side, well, you could just move it to the right-hand side. It doesn't matter. Okay. And sometimes they're unfactorable, so I just want to make sure you're aware is if they are unfactorable quadratics, then this method just won't work. So if you are spending 30 minutes and you cannot find a way to factor the problem or factor the quadratic, move on to something else because you either just can't do it or it's unfactorable, which means this method won't work. Now, it's always easier to solve these, or to factor, excuse me. It's always easier to factor when this number is greater than 0, meaning positive. So if you ever do have a negative a value, what I would recommend doing, just to make your life a little bit easier, is move everything to the other side. Literally reverse everybody. So if this is a negative a, then all you got to do is multiply everything by a negative to turn the a into a positive, and the b, if it's positive, will turn into a negative. If it's negative, it'll also turn into positive. You get my point. Just multiply everything by a -1, and it'll get rid of it, instantly making it a slightly easier problem. All right, so let's just dive into some examples here. All right, I already got a 0 on one side, which is awesome, and my a value is a nice +1. This is awesome. This is a very easy one. Let's factor this. All right, when you factor, you're literally taking a quadratic, a second-degree quadratic, and you're breaking it down to two linear factors. So I have x times x. Okay, now that's easy, because the only way in the world to break apart an x squared is x times x. Now I'm going to think about the 6. How could I multiply and get a 6? First thing that pops in my mind, 2 times 3. But I need a -6. So one of them has to be negative and one of them has to be positive. Well, I can make it a -2 or I can make it a -3. Either way, when I multiply them, I get -6. But I got to be careful because I need them to add to get this middle term. So I always think about splitting up the x squared first, x and x. Splitting up the back number, which I chose 2 and 3 here. And I could have chose 6 and 1. Never know. That could be the right way to do it. And then, but I got to get them to add to get that middle value. Because remember, when you reverse factor, which most people foil, multiply the first, the outside, the insides, and the last, you got to make sure that the outside and the insides make that middle. Because right, I already got the first down pat. X times x is x squared. 2 times 3, I know it's going to get a 6 as long as one of them is negative. But it's the outside, the 3x on the outside, and the 2x on the inside that need to make a -1. So I want the 3 to be negative and the 2 to be positive. That way I get a -3x and a positive 2x, and together they make the -x in the middle. And again, check your work. My goodness. Every time you think you're done factoring, just foil real quick. X times x, x squared, check, check. 2 times -3 is -6, check, check. Outside -3x, write it down if you have to. Inside positive 2x, together they make the -x in the middle. All right, now, because this is a number, you might say, no, it's not, it's an x plus 2. No, it's a number, right? X plus 2 is a number. I just don't know what it is yet because nobody's told me what x is. And this right here is also a number. So one of these two numbers, x plus 2, has to equal 0, or x minus 3 has to equal 0, because if the multiplying them together makes 0, then zero product property says one of them has to be 0. So now these are two very easy to solve. X equals -2, x equals +3, done. And remember, you could just say the answers are x equals -2 or x equals 3. Or you could do the little bracket, -2, 3. Don't use parentheses, because then it looks like it's a point. -2, 3, what? No. The bracket is insinuating that these are numbers that are the possible solutions. All right, guys, that's how easy it is to factor. All right, let's try another one. It's a little bit tougher. All right, now a couple issues here is I don't have a 0 on one side, and my a value is currently -2, which I don't like. So the first thing I'm going to do is I'm going to move the -2x to the right-hand side, making it a positive 2x squared, because I love when that value is positive. The -3x is going to stay. And I'm also going to subtract the 2 to the left-hand side to get my 0. Now I'm ready to factor. All right, now this one's definitely a little bit of a tougher factoring one, not going to lie, but you got to walk through it. First, how can I break apart a 2x squared? Well, 2x times x is the only way I can think how to do it. 2x times x is going to make guaranteed a 2x squared. All right, now how do I break apart a -2? Well, I could do a 2 and a 1. Okay, those are the only factors of 2, so that's easy. But it's like, where do I put them? Well, so now at this point, it's kind of like trial and error. So let's see here. Let's put the 2 right here and the 1 right here. And let's just see what happens. All right. So on the outside, I get a 2x. On the inside, I get a 2x. All right. Well, that's either going to make a 4x, or I guess if one of them is negative, it could make a 0x. That's not what I want. That's not going to work. Go back to the drawing board, try something else, and reverse it, right? I mean, the only factors of 2 are 2 and 1, so reverse it. Let's put the 1 here and the 2 here. So now, when I multiply the outside, I get a 4x. On the inside, I get a 1x. And ooh, that could get me a 3. Now, take your time. I do need a negative 3. So I actually want the 4 to be negative, 4x, and the 1x to be positive. That way it generates the negative 3. So again, breathe, check your work. 2x times x, 2x squared, bingo. Outside, negative 4x. Inside, 1x, that's going to make negative 3x. And then lastly, 1 times negative 2 is negative 2. Now you could use the zero product property. 2x plus 1 equals 0, or x minus 2 equals 0. And you guys can do 2 steps at once. Subtract the 1, divide by 2, x equals negative 1/2, or x equals 2. So my 2 solutions are negative 1/2 and 2. Very, very, very easy. All right, let's dive into the second option for solving quadratics, and that's using the square root principle. All right, now this method is one of the easiest methods, but the equation must be in a very specific form where you have something, I'm just calling it u right now, something squared equaling a number. Now it could be as easy as x squared equals 16, or it could be x plus 2 squared equals 16, right? But the point is I have something squared, and then a plain old number, constant on the right-hand side, okay? So again, I know that we talked about standard form as the ax squared bx plus c. So I guess the c is still there, but the u is just representing something. So in this case, if it's just x, well, then it's x squared. There's no b value. Or if it's x plus 2 squared, you'd have to multiply that out to find that b value. But the point is, to make this second option easy, you actually want to leave it in this form of something squared, okay? So note that I kind of wrote that here. I tried to. A is a linear factor. X plus 2, x minus 5, square, right? The inside has to be a linear factor, and C does have to be greater than 0, and I'll explain why that is right now. Let's just play a game where C is not greater than 0, like negative 5. Well, this, my friends, is an impossible equation. Because remember, when you square a number, you always get a positive. So if I square a number and get negative 5, that is literally impossible. There's no solution to there. Even if I put like an x plus 5 squared equals negative 7, it's still impossible because I don't care what x is. Doesn't matter. I don't care what x plus 5 is. If you square it, you're going to get a positive. So that C has to always be positive. Again, in this method. If you're doing the factoring method where you got to get 0 on one side, don't worry about that. All right, let's look at an easy one here. Here's very easy, right? X squared equals 16. All right, well, okay. Take the square root of both sides. I'm hoping somebody taught you at some point to get rid of a square. The inverse is a square root. The square root, the square and the square root basically undo each other because they're opposite, they're inverse operations, so you just get x. And then the square root of 16 is 4, but be careful. You're going to hear me say this a lot this year. Anytime you create a square root, don't do this if you just see a square. If you create the square root through your solving, you got to tag a plus or minus on your answer. Because if you think about that, right, 4 squared is 16. But negative 4 squared is also 16. So you got to make sure that you put that plus or minus there anytime you create a square root. Okay, so that's a really easy one, obviously, but I want to show you another one here. Once again, this is the form I'm talking about where we have something squared equals 16. So once again, I'm saying, all right, well, this is easy. I actually like this. How do you get rid of a square? Square root both sides. That's awesome. Okay. The square and the square root of inverse operations, they cancel each other out. All you get is x plus 3 equals 4. But wait a minute. I put that square root there, so it's actually 4 or negative 4. Then I'm going to subtract 3. So now I got to do this twice. Positive 4 minus 3 is 1. There's an answer. -4 minus 3 is -7. There's my other answer. Because I got to consider the fact that that 4 could be positive or negative. So that's how I get 2 answers. And I get 1 comma -7 inside the brackets. All right. Now, please be careful. I get a lot of kids that will, try to use this method on a problem like this. And I know I'm kind of messy here, but they'll say, oh, why can't I just do it? Okay, here's what I'm going to do. I'm going to do this, Mr. Project. All right, I'm going to add the x to the other side. I'm going to add the 6 to the other side. And I'm going to get rid of the square root, or get rid of the square with the square root, and they end up with this. X equals plus or minus the square root of x plus 6. Well, I'm sorry, you haven't solved anything. You still don't know what x is because you got an x on the left side and you got an x on the right side. So you can't do that. This second option can only be performed when you have something linear, like in this problem right here, x plus 3 all being squared. So the square is like on the outside of the parentheses. That's when you want to use this method. All right, so like I said, solving quadratics is not easy. There's a lot of different ways to do it. So this is the end of part 1 of this, and then we're going to move on to a video that I hope you watch immediately after this one for part 2, where we're going to go over the remaining methods.